Algebra, Chapter 6, Section 5, Graphing Linear Inequalities in Two Variables. Solving inequalities, we solve them the same way we solve equations, with one exception, and we'll talk about that in a minute. So on problem 1, we would subtract 17 from both sides. So our value would be x is less than 20. Notice the inequality sign stayed the same. In problem number 2, we would first subtract 3 from both sides, which would give us 2m is greater than 12, and then we would go ahead and divide by 2 so that m is greater than 6. The only time that inequality sign changes is when you multiply or divide by a negative number. The rest of the time the inequality stays the same. When looking at this problem, these are both equal signs, so you could solve this either using substitution or elimination. I'm going to use elimination. So to eliminate these, I'm going to multiply everything by a negative 2. Kind of a shortcut way there. So I have 13y is equal to 7. So y is going to equal 7 over 13, which is a single solution. Our newest vocabulary word is linear inequality. A linear inequality is any linear equation with an inequality symbol instead of an equal sign. So simply replacing the equal sign makes it a linear inequality. Here's our example. And we're going to, on 4, 5, 6, 7, and 8, change these to inequalities. Go ahead and try this. Pause the video and start the video and see how you did. And for problem 8, we want to circle the linear inequalities with two variables. Single variable, two variables, equal sign, single variable, and two variables and an inequality. So we have graphed equations, and those have created lines. An inequality creates a line that's either solid or dashed in a shaded region. All the points in the shaded region make the inequality true. To check whether the ordered pair is the solution of this equation, 3x minus 3y is greater than or equal to negative 2, you simply put the points in. So 3 times the x value, 3 minus 3 times the y value is greater than or equal than negative 2. Well, for the first one, we have a 0 and a 0. So 0 minus 0 greater than or equal to negative 2. Well, 0 is greater than or equal to negative 2, so yes, that is a true statement. Now let's try the second one. So 0 in for x, 1 in for y, is negative 3, 0 minus negative 3, which would be negative 3. Is that greater than or equal to negative 2? That is not a true statement. So only 0, 0 is a true statement in this case. When determining if a point is a solution of an inequality, we are actually deciding if that point lies either on the line or in the shaded region. So when we determine if the point 3, 6 is a solution of y is less than or equal to 2/3 x plus 4, we're going to put that point in the equation and see if it creates a true statement. 6 goes in for y, 3 goes in for x. We multiply. 6 is less than or equal to 6. Yes, 6 is less than or equal to, because it's equal to, 6. Take a moment, pause this video, and see whether 3, 6 is a solution to the problems 11 and 12. When you are done, please restart this video and check your answers. How'd you do? If you can't find any mistakes you might have had, make sure you bring this up in class tomorrow. What is the graph of y is less than or equal to 1/2 x plus 1? Let's go through some of the basic terminology. Before we start this, you really should be able to graph y is equal to 1/2 x plus 1. This is in slope-intercept form if it had an equal sign. So you should be able to determine what your b is, your y-intercept, and what your m, your slope, is. Let's look at problem 13. The less than or equal to means that it's less than or equal to. In this case, the boundary line. We haven't talked much about the boundary line. A boundary line is solid if the inequality has an equal sign involved. It's dashed if it does not. So in this case, we have an equal sign involved. If you look there, there's an equal sign underneath it. So your boundary line would be solid. So we're going to graph the boundary line. Now again, this is just using slope-intercept form. So we're actually going to graph this line. So at 1, we're going to rise 1, run 2. Rise 1, run 2. I'm going to do a lot of them because my lines are not typically very straight. Drop 1, run a -2. So my line might look like this. And we determine that's going to be solid because there's an equal sign involved. 0.00 is not on the line. So we're going to use the 0.00. So y is less than or equal to 1/2 x plus 1. And we'll put in 0. So 0 is less than or equal to 0 plus 1. Well, 0 is less than or equal to 1. So that makes that a true statement. So the line that contains 0, 0 should be shaded. So on this slide, we've had two new things. One about whether the line should be solid or dashed based on what the inequality looks like. And how to check to see which side of the equation needs to be shaded. It's the third time I've done this. Three, two, one. Let's take a moment and look at these graphs. As you can see, some of them have different lines. And different lines mean different things. This first line is dashed. That means it's going to use a dash symbol. A dash symbol means that you will use the inequalities less than or greater than. The second one has a solid line. Solid means you will use the inequalities less than or equal to or greater than or equal to. The third one is dashed. And the last one is solid. Now let's go about creating the inequalities that go with this graph. When doing that, the first thing you want to look at is where this line goes. So if we're looking at this line, we realize that it's vertical, so it's x equals, and it looks like x equals 4. But this is a dashed line. That means we are going to use either this symbol or this symbol. So once again, we look at it's x, and we know it's a 4, but what is the shading doing? As you can see, the shading is all the numbers larger than 4. Since x represents the shaded value, it's going to represent the numbers that are larger than 4. The next line is a horizontal line. That means y is equaling something. And y is going to equal 3. And again, I am looking at the shading of the numbers that are larger. So the larger numbers means the shading, or in this case, the y, is greater than 3. But we don't stop there. It's also going to be equal to 3. And we know that because this line is solid. And because it's a solid line, we're going to use the two inequalities with equal signs. This dashed line for the third graph is vertical, so x, and x equals -2. And the shading is the number smaller, so less than -2. And this line is dashed, and as a dashed line, we do not use an equal sign. So we will not have an equal sign here. The third one, we have a solid line that's horizontal, so y, it looks like y equals 5. The numbers shaded are less than 5, so y, the number shaded. represented by y, is less than 5. We can apply that knowledge to problems 19. Looking at the first graph, we know that this graph is a dashed line. And this graph, because it has an equal sign, is a solid line. Now, it's a bit harder to describe the shading if we can't see the graph. But what you do is you look at a point like 0, 0. So we would put the 0 in for x and say, is this a true statement? Is 0 less than negative 5? Since that is not a true statement, the side with 0, 0 is not shaded. In the next one, we'd put in 0, 0. Y value is 0, less than or equal to 2. That is a true statement. So that means the side with the point 0, 0 is shaded. Steps to graphing linear inequalities. First, write the inequality in slope-intercept form, that y equals mx plus b form. Then graph the equation. You're going to use a dashed line for either less than or greater than. And you can use a solid line when there's an equal sign involved. Step 3, test a point on one of the half planes to find whether it's a solution of the inequality. A good point to test is the point 0, 0, unless it's on the line, because then it won't work. Step 4, if the test point is a solution, shade that half. If not, shade the other side. If y is less than or equal to negative 2x plus 1, we first check to make sure it's in slope-intercept form. It is. So I'm going to plot that. And then I have a rise of negative 2, run of 1. I have a negative slope here. Yes, I do a lot of dots so that my line can be straight. I can also go up 2 and over negative 1, up 2 over negative 1. And this is an equal sign involved. So with an involved equal sign, I can draw a solid line. Not a very good solid line, but a solid line. And then I need to determine which side is shaded. To do that, I'm going to put in a point that's not on the graph. Now looking at this, point 0, 0 is not on the graph. So I'm going to put in point 0, 0 to see if the side with 0, 0 is shaded or the side without it. True statement would make this side shaded. Untrue would make the other side shaded. So 0 in place of the y is less than or equal to negative 2 times 0 plus 1. 0 less than or equal to 1. Is that a true statement? It is. So the side with the 0 is going to be shaded. The graph 9x minus 3y is greater than or equal to 18. I first must get it into slope-intercept form. So I'm going to subtract 9x from both sides. Then we divide both sides by negative 3. Remember, I divide by negative 3. So now I know that my y-intercept is negative 6. 1, 2, 3, 4, 5, 6, negative 6. And my slope is 3. Also know, by looking at this equal sign, that this is going to be a solid line. So I'm going to draw a solid line here to the best of my ability. Now, I don't know which side is going to be shaded yet, but I'm going to put in the point 0, 0 and see if that side's shaded. So if 0, 0 makes a true statement, I'm going to shade this side. If it does not make a true statement, I'm going to shade the other. So 0 is greater than or equal to 3 times 0 minus 6. So is 0 greater than or equal to negative 6? That is a true statement. So this is the side of my graph that gets shaded. We are to write an inequality from a graph. We know that the boundary line is dashed, which tells us that we'll have a less than sign or a greater than sign. We have a slope of 1/3, that's our m, and a y-intercept of negative 2, which is our b. The first step is to write an equation in slope-intercept form. So y equals mx plus b. Well, our m is 1/3, and our b is negative 2. Our second step is to realize that a boundary line is dashed and the area above the line is shaded. So we know that we will not be using these because we know it's a dashed line, and those two would make it a solid line. Now the area above the line is shaded, which means that our y is above, which means our y is greater than. So this is the inequality we will use. So y is greater than 1/3 x minus 2 is our inequality. Lesson check. What follows is your math success. Please fill out both. Bring any questions to class tomorrow.